This video goes over the 9.2 assignment. The area of a circle is found by taking pi multiplied by the radius squared. The radius here is 7, so we plug that in. They want to leave your answer in terms of pi, so it's just 49 pi yards squared. 7 squared is 49. The circumference of a circle, there's two formulas, pi times diameter or 2 pi r. In fact, that's where pi comes from. How many times the diameter fits around the outside of a circle. Here, since they give us the diameter, 5, it would probably be easiest to use this formula. And the answer is just 5 pi meters. So the area of a circle is pi r squared. They give us the diameters of 3 different pens, circular pens, not like the pen you would write with, but a pen you would keep a horse in. So we can find the radius by taking half of these. So 17.5 squared times pi, 25 squared times pi, and 33 squared times pi. Now here we're actually finding to the nearest tenth. So if you multiply by 3.14, you'll get the wrong answer. But if you use the pi button on your calculator or your phone's calculator or whatever, you'll get 962.1, 1963.5, and 3421.2, all feet squared. The formula for area of a regular polygon is area is equal to the apothem times the perimeter divided by 2. What we are really doing there is we're taking the area of each of these 1, 2, 3, 4 triangles, because it's base times height divided by 2, and the perimeter covers all the bases added together, and the apothem is like the height. Though they only give us the apothem here, we can figure out the length of the base by using some Sohcahtoa Trigonometry. So first of all, there's 4 angles here. So this one is 90 degrees. That one's 90, that one's 90. All 4 of these angles are 90 degrees. So when we cut that in half for this triangle here, that means we're looking at a 45-degree angle. Down here is 90, this height is 12. If you remember anything about 45, 45, 90 triangles, or just isosceles triangles, this is going to be equal. If you didn't remember that, you could use the idea that the tangent of 45 is going to be equal to x over 12. And if you took 12 tan 45, as long as you were in degree mode, not radian mode, you're going to get 12. That tells us that if this is 12, so is this. So one side length is 24. The perimeter is equal to 96. So plugging things into my formula, the area is equal to 12, the apothem, times 96, the perimeter, all of that divided by 2. And that's how we get 576 centimeters squared for the area. Number 5, same thing. We count the number of sides. 1, 2, 3, 4, 5, 6, 7, 8. So the central angle for this particular triangle here, for this triangle rather, is going to be 360 divided by 8. So we're looking at 45 degrees. And since we are only looking at half of that, we're going to be looking at 22.5 degrees. And this is 90. And the 2 feet is the apothem. And we want to figure out x, the base. So we can use Sohcahtoa Trigonometry. The tangent of 22.5 is equal to x over 2. So 2 times the tangent of 22.5 is equal to x. Now if we stop here and round, our final answer is going to be wrong. So let's think about what this actually represents. This represents 1/2 of the base. So I want to double that again. So 2 times 2 tan 22.5. And I'm going to multiply that by 8. Because there are 8 of these bases. And that's going to give me the perimeter. So this whole thing is equal to the perimeter. My formula says apothem times perimeter divided by 2. So that's 2 times all of this divided by 2. The 2's are just going to cancel out. Round at the very end. You'll end up with 13.25, which if you round to the nearest tenth gives you 13.25 becomes 13.3. Excuse me. A square has 4 sides, a hexagon has 6, an octagon has 8, and a decagon has 10. So if I take 360 divided by 4, I get 90 degrees. 360 divided by 6 is 60 degrees. 360 divided by 8 is 45 degrees. 360 divided by 10 is 36 degrees. So I'm going to start by figuring out my central angle. There are 1, 2, 3, 4, 5, 6, 7 sides, so 360 divided by 7. That one's a little bit tricky because it comes out as a decimal, and we don't want to round at this point, so I'm actually going to leave it as that, but I know I'm going to cut it in half. So if I take 360 over 7 and multiply that by 1/2, that's the same thing as saying 360 over 14. That's still a decimal, but I'm going to use it as my angle. Just to give you a ballpark, it's about 25.7 or so. So I'm going to blow up this triangle here. This angle is this right here, 360 divided by 14. This apothem is 5, that's the dotted line, and I want to figure out x. So the tangent of 360 over 14 is equal to x over 5. So 5 times this is equal to x. I'm just going to move that 5 over like that. And once I figure that out, I'm then going to double it. And then I'm going to multiply it by 7. And that'll give me the perimeter. So to find the area, I'm going to take the apothem times the perimeter divided by 2. So the apothem is 5. I'm going to plug that in. And whatever I get here is my perimeter. So plugging all those things in and rounding at the very end, I get 84.27, which is just 84.3. Number 8, if I consider this as the center of the triangle, I'm looking at 1, 2, 3 triangles within that triangle, if that makes sense. So the area is equal to 3, the apothem, times the perimeter divided by 2. So I have to figure out the perimeter. So I'm going to take one of these triangles. I know that is 90. I know that 360 divided by 3 is 120, and if I cut that in half again, 60 degrees right here. So this is 3, this is x. So if you remember things about 30, 60, 90 triangles, there's a shortcut. If you don't, we can say that the tangent of 60 is equal to x over 3, or 3 tan 60 is equal to x. So I know that's half of one of the bases, so I'm going to double this. And then there's 3 bases, so I'm going to multiply by 3, and that gives me the perimeter. I'm doing this just to avoid rounding before the very end. So I'm going to take 3 times all of this, divided by 2. If I do that correctly, I get 46.76, which is just 46.8. Find the area of the regular polygon, round to the nearest tenth. There are 1, 2, 3, 4, 5, 6, 7 central angles here. Again with that odd decimal. If I'm going to cut these triangles in 2, it's really like there's 14 exact angles. So that angle there, if I blow this up a little bit over here, is going to be 360 divided by 14. This is 90. My base of 5 is cut in half, so here's 2.5. So I can rewrite this as the tangent of 360 divided by 14 is equal to 2.5 over x, x being the apothem. So if I multiply both sides by x and divide both sides by tangent of 360 over 14, I get this. And this is where having a graphing calculator works out really well, because if you take that perimeter, which is going to be 35, 5 shows up 7 times around this figure, and you multiply it by everything here exactly, and then divide by 2, you're going to get a more precise answer. If you try to round too early, it's going to be a little bit rough. So 2.5 divided by the tangent of 360 over 14 is 5.19130349143 if you remember to be in degree mode. If I multiply that by 35, and then I divide by 2, I get 90.847. So round to the nearest tenth, that's 90.8. Last couple questions, multiple choice. So if this is my triangle, I have 1, 2, 3, 4, 5, 6, 7, 8 sides. 360 divided by 8. This is going to be 45 degrees. Cut it in half again. This is my triangle 22.5, 96x. So the tangent of 22.5 is equal to x over 6. And I'm going to be multiplying this by a few different things. They want to find the perimeter. So if I find x, that's going to be 6 times the tangent of 22.5. Whatever this is, I'm going to double it because x here and x here together makes up the base. And then I'm going to multiply it by 8 because there are 8 bases. Doing all of that gives me 39.76. B is the closest one. They want to know ratios comparing a circle's circumference to its diameter. So circumference is equal to pi times diameter. Which one gives the value of pi? So we're going to divide by diameter on both sides, I guess. And we have c over d is equal to pi. So F. The last one, they're talking about a circular tabletop that has a diameter of 2 feet. So 2 feet here. They want to paint a rectangle that is 2 feet by 1 feet. So that would be something like this. And we can see right away that the rectangle doesn't even fit. That distance of 2 feet, the diameter of the circle, is only at the farthest points. So to go 1 foot over, 6 inches each side, it would go off of the table. So B is going to be the biggest immediate problem.